Hello and welcome to this video on the first lesson of our new trigonometry chapter. We are going to be starting off looking at some things that can be modeled in a way using trigonometry and solving problems using trigonometry in general. So in this situation, we have a Ferris wheel, and we have some people who are going on a Ferris wheel at a end of school year amusement park trip. And this guy, Carlos, is going to be riding this ride. And we have some important information about the ride itself in that the wheel has a radius of 25 feet and its center is 30 feet above the ground. And we're going to try to figure out how high above the ground he's going to be at different positions on the wheel. So to start off with, we have three questions that we're going to be working on answering at the beginning of this lesson. So the first question that we're going to be answering is how high up off the ground Carlos will be when he is at the very top, how high will he be when he is at the bottom of the wheel, and how high will he be at the positions that are the farthest to the left and the farthest to the right on the wheel. And these are all questions that you can try right now during this video. We are going to start off with question number one. How high above the ground will Carlos be when he is at the top of the wheel? So if we know that the radius of this wheel, is 25 feet. The radius, and I don't know if you can see that, so I'll try it somewhere else as well. So like radius from here to the center right there, that is going to be 25 feet. We also know that from the center of the wheel, kind of round right there, to the bottom is 30 feet. So if I knew that this was 30 feet, and I knew that the radius itself to the top is another 25 feet, that means that the answer to how high above the ground he will be at the very top will be 30 plus 25 for a total of 55 feet off the ground. Nothing too complicated so far. How high will he be when he's at the bottom of the wheel? Well, we already know from what we drew earlier that from the middle to the bottom of the wheel, that's still the radius of 25. It's a little dark there, but that's kind of from right here to right here. We know that the feet off the ground is 30. So if we look at the difference between 30 and 25, that's this part right at the bottom, and that would be only 5 feet difference. So you would find this answer by doing 30 feet from the center minus 25 feet for the radius of the wheel itself to be a total of 5 feet off the ground. So that seemed to be a pattern that we kind of added or subtracted 30, added subtracted 25 feet for the radius from the 30 feet above the ground the center is. Lastly, we have number 3. We are looking at the farthest left and farthest right on the wheels. So these 2 points I've circled in purple. Now both of those points are at the center, and we already know that the center is 30 feet off the ground. So for both of those points, they would be like 30 plus 0 or 30 minus 0, which obviously both equal to 30 feet off of the ground. Now we're going to move into the more trigonometry-centric portion of this lesson here. So if we are looking at this next paragraph, so the wheel itself, as you can maybe see in the picture already, has 10 spokes. And Carlos wonders if he can determine the height of the positions at the ends of each of these spokes as shown in the diagram on the following page, which we'll look at next. And you guys have learned about right triangle trigonometry before. You may have done the review assignment as well. And this will be a theme throughout the chapter in general. And we're going to be working on using trigonometry to solve for those missing points. So let's turn to that now. So if we kind of look at this whole Ferris wheel here, you kind of see that we have a lot of stuff going on. But remember that our center right here to the bottom is still 30 feet. Was it 30 feet off the ground? Yeah. So 30 feet off the ground. And it might be easier to see if we zoom out just a tad. And we have each of these spokes, so you can kind of see the spokes as they go around the circle. All of those are going to be the same distance from the center. They're all 25 feet for the radius of this Ferris wheel. So we know some answers on this already. We already know A and F are both 30 feet off the ground. We know the center of the circle is 30 feet. So the two ends right here and here, A and F, are both 30 feet. So we could say points A and F are both 30 feet off of the ground. Okay. So now we're going to be trying to use what we know already about right triangles and trigonometry, and we're going to zoom in on this a little bit more now that we've seen what the whole circle looks like. So we know A and F. So the ones we're going to try next, we're going to basically kind of look at the ones where point B and point C are first. So I recommend looking at this circle and trying to draw it for yourself and thinking about how you would approach it using right triangles and trigonometry that you've learned about before, because it is certainly possible. And that's what we're about to do together. For starters, we're going to look at point B. So we already know that if we kind of look at the whole circle, all right, so we've got our circle here. So we're going to look at point B. We're trying to figure out, well, so if we know that point A over here is 30 feet off of the ground, so I just need to figure out how much higher B is off the ground than A in order to get my final answer for how far B is off the ground in general. So the distance for B to where A is would be that right there. So that's going straight downwards. So that means that we have a right angle right there. And we know some more information as well. So we also know that from the center to B is the radius of our Ferris wheel. They already told us a couple times that that is going to be 25 feet. Now that we have that 25-foot radius labeled, we're going to use some trigonometry here now. In order to use trigonometry, we need angles. We mentioned and we can see that, well, the whole circle is 360 degrees. And we also know that there are 10 spokes on this. So that means that the number of degrees between each spoke, well, then has to be 36 degrees. So that means I could label this angle right here as 36 degrees. So what I need to do now is I'm going to use trigonometry to figure out what this blue line segment is, and then I'm going to add it to 30 to figure out the height off the ground for point B. So that's what I'm going to do next. So the missing side right here is going to be my x value right there. And we need to think about, well, if I have my angle here, this would be the opposite side. This x side would be my opposite side, and then I have the 25 as my hypotenuse side. Well, if I have opposite over hypotenuse, that should make you think of sine. So I would write a little equation here. The sine of 36 degrees would have to be equal to x over 25. So we have an equation there. So in order to solve this equation, I would multiply both sides by 25, meaning that I would have 25 sine of 36, and that would be equal to x. We need to grab our calculator in order to solve that. So Key thing with your calculator is you want to check your mode first. We're dealing with degrees, so we want to change our mode to degrees. It may already be in degrees, but make sure to check that before proceeding. So we're now doing 25 times the sine of 36. So we get 14.7 feet. Well, we already know that that's how far above 30 feet it is. So it really would be 30 plus 25 sine of 36 degrees, and ends up being about 44.7 feet off the ground total. And so we have a little equation there. We would basically did 30 plus the sine of 36 is equal to 44.7. So we have solved for point B. Let's move on to point C now. So point C has a lot of similar elements. We have a kind of a new x value for this distance above 30 that we are going to need. So they're in blue. And so that's our new x value. Now, if we have the 36 degrees is one spoke, well, two spokes has got to be then equal to 72 degrees for both of these spokes added together. So no, just like last time, we're missing, we know that our spoke here is 25 feet, so we can use the same strategy for point C. We can do the, we can find the sine of 72, and that is going to be equal to x over 25. So we would do 25 sine of 72 from there is equal to x. And then we know there has to be 30 more than that, whatever that answer is for x. So I would do 30 plus the sine of 72 is equal to x. And I can just put that right in my calculator. 30 plus 25 sine of 72 degrees. And that is 53.77. And so we have found that new answer. Now, if we kind of keep going around the circle to point D and E, we could use those same strategies, because we could do, for point E, we could draw a line down here. We know that one spoke is 36 degrees, and then two spokes is 72. No spoke right in the middle, but we already know that height already. So I could do basically the same exact thing. But remember that circles are basically symmetric. So I could draw a line here. So it'd be 36 degrees and then 72 degrees. So D and C are the exact same heights off of the ground, just like how B and E are both the same heights off the ground. So E equals point B, and D equals point C. And those are going to be equal to each other. So that is something to file away for later for sure. Now we have a similar thing going on in the bottom of the circle, in that we have some symmetry going down here. So it's hard to see, but these bottom 2 points are H and then I. And these are J and G. So J and G are going to be the same height off the ground. H and I are also going to be the same heights off the ground. So let's see how different that these two are going to be. So let's start with point J right underneath point A. So I could still find this x value right here. So that's our unknown value. We know that this radius is still 25. This is only one spoke right here. We still have 36 degrees. And so that 36 degrees right there, well, we have from here, we still can use sine. The sine of 36 degrees would be equal to x divided by 25. And so we have that set up, but now we have a slightly different result going on. We're not this x amount of feet above 30, where A was. We are x amount of feet underneath of 30. So what that means we have to do is 30 being subtracted. Oh, so first we had to do 25 sine of 36. We already know what that is. We already know that it's 14.7 from earlier. So what we're really doing here, like I just mentioned a moment ago, is 30 minus 25 sine of 36 degrees. And we can do some quick calculation. 30 minus 25 sine of 36. And that's 15.3. Only 15.3 feet off of the ground. So now all we need to do is find point I, and that would wrap up this problem for us. So something we can do, we can basically are going to be doing something similar to our x value from earlier. We still have see that blue angle right there is still 72 degrees like we used earlier. We're still looking for our x value for that blue line starting right here and ending at point I down at the bottom there. And we still know that our radius is 25. So we know that our value that we're looking for there would be the sine now of 72 degrees would be x over 25. So now 25 times the sine of 72 would be equal to x. And now all we need to do is 30 minus 25 sine of 72. And that gives us an answer of 30 minus 25 sine of 72 degrees. And that is equal to 6.22, or just 6.2 feet off the ground. So we have a very similar equation for both instances. Especially with what we just worked on, we just up x by x or down by x. And it was very similar other than that. And to find all these 4 points on the right side, for when you're beneath the middle of it, you would be 30 minus 25 sine of that angle that you're making with the center of the wheel. Or you would have 30 plus 25 sine if you're above it. So we could kind of summarize that on the bottom. So we're either using 30 plus sine, or we are doing 30 plus 25 sine of theta, and theta is an unknown angle variable, or we were doing 30 minus 25 sine of that angle. And there are more things going on here. Like we already mentioned before that the points on the left are symmetric. So points on left side are symmetric to points on the right side of the circle. Well, in this case, we'll call it a Ferris wheel. And so that is how we would find all the other points. And F, obviously, we found at the very beginning. And so we now have a way of finding the height at any point along our circle. And in actuality, we can really generalize this to not just a certain amount of spokes around the wheel, so any number of 36-degree angles. We could generalize this to any radius circle. We could generalize this to any height off the ground, any amount of degrees around the circle. And depending on where we are, you'll be able to find kind of the height off of the ground. And in this case, you might be able to then translate x instead of degrees to time around the circle. And that would be a way to apply even more to the real world. And this shows how we can use a periodic function like sine to find and apply to real world situations like a Ferris wheel height off the ground. And that concludes our first lesson of our trigonometry chapter. Thank you for watching.